So, hello everybody. Thanks for coming to our monthly computer vision meetup. I hope that would be more showing up because we have 16 people registering on the meetup. Probably the nice weather, they are all at the Donaukanal. Yeah, not here. But thanks for showing up. I'm Daniel, I'm a co-founder at Anyline and CTO. I'm organizer of this meetup, and I've also Jakob and Michael. Jakob also co-founder, CMO, and Michael helping us with the organization. Yeah. Plus, we're also live streaming all the meetups. That's very cool. So you don't have to be here. You can also watch it on YouTube if you want to. And as always, we have the drinks. They are sponsored by Anyline. So feel free to grab beer, focale, whatever you like. Yeah. And as also always, we are looking pretty much for speakers. Most of the time, I'm the only speaker, yeah, unfortunately. We had planned that Wikitude would join us today, but they canceled on a short notice, and they probably will join in May or June. So they will come then and give a few AR talks. So for today, I had to come up with something on short notice. So that's then our today's agenda. I will shortly say something about WeAreDevelopers, because we got a promo code so everyone can get 15% off. And I will tell a few words about WeAreDevelopers. You should all go there. It's a huge conference here in Vienna. And we have also 2 free tickets to give away. And how we are doing that is we are playing presentation karaoke. That means someone here in the audience can win a ticket. So we have 2 slots. We have here 2 presentations. The first one is called The End is Near. And the second one is called Machine Learning is Fun. And for these 2 presentations, we have 3 slides where you don't know what the slides are and you have to present 10 minutes about them. And if you do that, you win a ticket to the WeAreDevelopers. So, anyone who wants to present and win a ticket? It costs
around 400 euros.
Yeah, and we have 1 volunteer. Okay, do we get a second one? Okay.
Still have time.
Yeah, it's just for fun. The worst thing which can happen is that we all get a nice laugh out of you. But it's not so dramatic. Okay, then we have our 2 guest presenters. Who wants to do the first one? You? Okay. Now, at first, there's something about WeAreDevelopers. Then it's your turn. Then it's my turn to how to trick neural networks, what I came up with today, probably or yesterday in the evening. And the last thing is then machine learning is fun, which is then your turn. Okay, so a few words about WeAreDevelopers. Wait. Oops, that's not the first slide. So, yeah, WeAreDevelopers, the World Congress. It's this year, it's a 3 days conference, and this year they told me they improved very much. Last year it was very packed, the area was very small. This year they have just double the attendees, but 4 times the space. And it's the largest developer congress in Europe. It's here in Vienna, in the Austrian Center Vienna. You shouldn't miss it. 150 plus speakers from 50 plus countries, 50% senior management. Really awesome. I don't know, I just got the slides and I have to present them. So I'm just coming up with something here. Because they didn't want to come here and present themselves.
Don't say that, it's recorded.
Yeah, so there are really 3 days packed with a lot of innovative stuff and a lot of topics. Last year was a lot JavaScript focus, but this time they have also IoT, robotics, AI, machine learning talks, VR, augmented reality, CI, product lifecycle, and testing and security, and many, many more cloud platforms, server-side technologies, native, hybrid, and progressive apps. Yeah, whatever you can imagine in the computer science space, you will have you will find some talks here. And they have 10 tracks, which is nice. So you only see a 10th of all the sessions. But maybe it's not so packed. That's really nice. Except if everyone wants to go to the same track, then it's still packed. They have a lot of workshops and hackathon coding competition. There's an exhibition area where a lot of startups or companies exhibition stuff, and huge community spirit. I think I'm doing great. And yeah. There are really high-profile speakers. They have Steve Wozniak, when you get the chance to have Steve Wozniak telling you something. So that's really amazing. And also John Romero, which also went there last year, and he gave an awesome talk. Also his wife, Brenda Romero, and I don't know, a lot of very interesting, very famous people, probably. And we have also, for the ones who didn't participate in our presentation karaoke, we have discount codes. As said, 15%. Just use the code annoyed to type that in 15, and you get 15% off. And I think it's valid until 8th of May or something like this. Yeah, so grab your ticket soon, and we have this code works for the first 100 tickets. So go and buy your tickets now. Yeah, that's it from the WeAreDeveloper side. Thank you. And now we're starting with our first presentation karaoke. Just here. Okay.
All right. I'm not the best public speaker, but somebody told me I need to learn. So, as everybody know, the end is near. The end is near for humans to work. The end is near for human labor within the slavery. So we need to transform. Okay, so the end is near for labor, for human slavery. And as we can see right here, machines are learning fast. And we can train them to do our tasks for us, from everyday tasks to simple tasks. We can let them cook for us. We can let them sort stuff for us. And what you can see here is the computer vision is realizing what item to grab and translating this into or giving the machine the right signal, which item to grab, and then the machine is grabbing the item. This is especially interesting for recycling areas. So if we talk about garbage recycling, we can transform. We can make the process of recycling a lot faster, and we don't have to recycle ourselves. We can let the machines do that. I will just go to the next slide because that one is much cooler. Right here, it's not a slide as well. It's another video. By the way, hi to our YouTube community. So let's just have a look for some seconds, and then we come up with what's happening here. Okay, as everybody can see, the ball is moving into the picture, and our algorithm is that's actually not coming from the military industry from the US, but it's coming from some Texas people that are just crazy to shoot stuff. And actually that guy invented the machine for protecting his house because they have a lot of wild boars there, and he doesn't want to kill them but just scare them off, so he sets up this machine, and all the wild pigs just run away, and they are scared forever. So this is just a fun project, but as we can see, it's pretty good for showing how quick and how accurate computer vision can be, and transform that into movement on the X, Y, and Z axis. We can do a lot of stuff with that. Okay, last slide, last video for today. Let's have a look. Okay, that looks like Terminator to me. Yeah, isn't that the scene from Terminator? Do you remember that? Yeah? Okay, yeah, cool. Yeah, Terminator, one of the first examples in of the people, I think that one is from the 80s. So that's what people in that time thought is possible. Right here you can see facial impression recognition, which is possible already. We can do that now. So people had a good idea in that time of what is possible in the future, or what might be possible in the future. I hope we see less of the war machines and more of the good stuff. So let me end this short presentation by telling you, by asking you questions, actually. So any questions to the content that I presented to you? Okay, thank you then.
I think that was very well done. And you can thank then Martin here behind. He did the slides for you, so. So I think he clearly won one of the tickets. Well, you have the codes then? Okay, that was fun. Thank you. So now we come to my talk. Probably not that funny. I want to tell you something about short talk about how you can very easily trick neural networks. So what am I doing? I'm basically doing something like this. Yeah, really feeling like a hacker, whatever. Yeah, so what I'm actually trying to do is use a neural network like the inception model, which can very accurately classify 1,000 different things. And I will try to make this picture of Willy, our office dog. You don't see it very good now. And I want that the inception V3 model classifies it as a toaster very accurately. So that's my goal. Without modifying a lot of the image. So image should basically look the same, and I want that the inception model classifies it as a toaster, normal model. So what is my motivation behind this? So there are a lot of neural networks now also used in security approaches, or also, for example, the Willy example. I want to sell Willy on eBay. I want to do that now. And it's not allowed to sell dogs on eBay. And there have hundreds of millions of stuff get sold every day on eBay, and then it cannot look over the stuff manually. So they are also using neural networks, and they probably check if in the picture there's a dog. And if I modify the picture a little bit that it's classified as a toaster, maybe I can trick eBay that I can sell Jakob's dog. That could be a motivation. So how does this work? So first of all, we need to look at how does training of a neural network basically look. So untrained neural network, CNN, would predict maybe that this image, 3% it's a Labrador. What I actually want is that my network gives an output of 100%, or maybe not 100, because then it would be probably overfitting to this image or this kind of class, but near to 100%. And then I use this with backpropagation, gradient descent, or whatever, to tweak the network weights a little tiny bit, that the next time it's a little bit closer to the 100% prediction. So that's basically what's happening while training. So normally if you say that's the actual output prediction of the inception model, if I just put Willy in there, it's saying 91% it's in Labrador. If I modify Willy a little bit that he gets a mustache, it's still not tricking the neural network. It says 63% it's in Labrador. I don't know why there's women. I missed that one on my slide. It's 63% then Labrador. And what I actually want, so this is already my hacked tricked image. It looks exactly the same as the first image for the human eye, and it predicts 99% that it's a toaster. So how am I doing this? So normally for neural networks, if you imagine it very easily, there are two classified things, and there's the space between it where it's trained, and normally it should look like this, so it's a perfectly trained neural network. And what I want to do is I want to move Willy up in this other space, basically. How does this work? So I'm using basically the same approach as I would do if I train a neural network. I just don't train the neural network and change weights in the inception model. I just tweak the image pixels a little tiny bit that make the prediction slightly more near to a toaster. And I'm just doing it little tiny bits and pieces, and so the image doesn't really change for the human eye. So I'm just allowing a change of 0.01% of the pixel value, plus minus. So for the human eye, the image doesn't really change, but for the neural networks, it totally changes, and it's clearly a toaster. So, as said, I'm using the inception V3 model. I did this, I tried this out, and so to spoil the output, that's the output. So on the left, that's the original Willy image, which is classified 91% as a Labrador, and this is clearly a toaster with 99% accuracy from the inception V3 model. So how does stuff work? I can show you in a quick live demo. So here we one more time have the original Willy, which is called Willy BNG. And we have the hacked Willy. Clearly look totally the same. How this stuff works. So can you read this? That's my speaker no stuff. Here I have basically two Python scripts. I'm using Keras with TensorFlow as a backend. So the first script is just loading inception model, loading Willy, adjusting the values of the image that the inception model takes it. Inception model takes values from -1 to 1, so I'm just changing the values there, and then I just predict and print the prediction. So I can do this now with the, can you read it? I'm using the prediction now with the original Willy BNG. Then it takes a little bit of time. Those stupid warnings. So it says Labrador Retriever with 91.45%, which is very good because it's correct. So then I use a second script, Python script. That's where the hackery is going on. It's also just loading the Willy BNGs, it's loading the model, and it's, as I said, I have the max change above and max change below. That is the changes are not so severe, because if I don't do that, you could actually see then in the hacked image some pixels totally changed in value. But I don't want this, so I have an upper and lower boundary. I have a cost function and a gradient function, and then I'm just giving the hacked image to my model, getting out the cost and gradients, adjusting the hacked image with the gradients and the learning rate, and clipping it to the max change above and below, that the changes are not too severe. And then I'm printing it out, and I'm repeating this until the cost is smaller than 0.8. So until I'm 80% sure that it's until I'm changing the image so long as the inception model FOUT3 has a minimum of 80% likeliness that it's a toaster now.
Could you explain the parameters? Does it mean your pixels are only changing in value by 1%?
Yeah, the pixel values are changing a maximum by 0.01 in value. Okay. So very, very small changes. So that the pixel values are from -1 to 1, and I only allow changes from 0.01 maximum. So that's why you don't see any changes in the Willy image, because the changes are very, very tiny.
And from where does the pattern for changes come? Is that like a picture of toaster? The pattern for the changes? Because are changed, I assume, with some kind of pattern built randomly.
Yeah, the pattern is just my gradient function, which you normally would use to adjust the training, the weights. But I use the gradients to not adjust the weights. I adjust the image. That's
basically you're trying to overfit the image that you have to the model that you're using, right? So that it gets close to. Because another model you might get something entirely different.
No, actually that would then work also on a different model. If this different model also has a Labrador and a toaster and is trained with also the ImageNet database, then it would also give the same prediction. I'm not changing anything in the neural network. I'm only changing the Willy image. Yeah. And it would also then work on different neural networks trained with the same or similar training material. Yeah. If the neural network is trained with totally different training material, then it would probably not work. Yeah. Yeah, if it's trained with totally different training material, then it's maybe also not working or giving some different output, yeah. And if I run this, then this would now take probably half an hour, because it takes 2,000 training steps until the image is then over 80% likely that it is a toaster. So I'm just starting it and I'm not running it through. So that's how you can see it's, in the beginning it's very, very unlikely that the Willy image is a toaster, and it's small getting likelier that it's a toaster. And I did this morning, and it took me 2,400 steps. So I'm stopping this now. And you can see it here that I did this, and it took 2,379 steps. And as it progresses, it gets then, in the beginning it's very slow in the changes, and then in the end it gets very fast to the predicted likelihood. And then the hacked image, I just save it as the hacked Willy image, which you saw here. That's then just a saved image. And if I'm predicting now this hacked Willy image, the neural network will give you an 89 point something percentage that it's a toaster. So 89.73% confidence that it's a toaster.
It's even more higher than the level before.
Yeah. But I just find it funny that with so small and little tiny changes in an image which no human eye can see, you can totally easily trick a neural network that the prediction is something completely different. And you could also print this hacked Willy image out and then it still would recognize it wrongly. So yeah, just very interesting from my perspective, and that's why I just wanted to show it to you in a small talk. And you can also, the prevention of this, there are not a lot of strategies. You can just generate such image and then use them also for training. That's what you can do. Or there's a second approach, which is very new, where you can have a second neural network, which is also then I don't know how it actually works. You have a second neural network which mimics the first neural network, and that you can use then for getting notice of such hacked images. I don't know in detail how this works. Yeah, I don't know in detail. Maybe Martin, do you know how this works?
One of the networks is learning to generate images, and the other one is trained to recognize between real and fake images. It's basically it's called Siamese networks.
Have you looked at the diff of the two images? Do you see something, or is it just random noise?
It's just random changes. So you don't see a toaster in the TIFF.
In the diff?
No.
Okay.
It's really just random changes. But the neural network is then very confident that it's a toaster. Hmm?
There were exactly the CME network for changing the image of a horse into an image of a zebra,
Hmm?
and the other network was trying to recognize it if that's a real zebra or a fake zebra.
Hmm?
And the problem was that it worked till some time, but then this original network learned to trick the CME network, and the thing was that this original network could create a zebra out of a horse or horse out of a zebra, and then, for example, restore the original stripes of a zebra, but the other algorithm couldn't recognize the difference because the changes were hidden so well that the other network couldn't recognize. So actually,
Yeah.
the CM network is also already broken.
Okay, yeah, that's very interesting. Yeah, there are no real solutions other just to train with them, or yeah. But if this is also already broken, then yeah.
I have a question. How much different objects is your neural network able to predict?
Yeah, this Inception V3 model is trained on the ImageNet database, and they have 1,000 different objects. That's one of the standard image libraries which you use for the comparison of different neural networks and in all the competitions. Yeah.
That's an already precompiled model, pre-trained model.
Yeah, I used a pre-compiled, pre-trained model of the ImageNet database from the Inception V3.
So basically what you were doing is changing the image exactly against this model, against this network.
Yeah. Any other questions? Yeah?
Have you picked toaster just randomly, or was it some best case? Or?
No, I thought I want to sell Willy as a toaster on eBay. And I'm trying this now. Yeah, it was just random. Yeah.
And the gradient function was exactly designed for this case to create the toaster out of any image.
What?
The gradient function, your gradient function
Yeah.
was designed to create a toaster out of any image.
Yeah, the gradient function is just a normal gradient function which TensorFlow provides me, which I normally use for training of the neural network. So it's completely normal backpropagation with gradient descent, and I'm just not changing weights in the network, I'm just changing pixel values in the input. Yes?
Make a product out of it and have people to cover themselves as toasters.
Yeah, that could be possible. Yeah, as you can also trick it if it's printed out. There are already occurrences where self-autonomous cars were tricked with such things.
When you change the stop sign.
Yeah, you can change your stop sign to something else, which looks like a stop sign, but the autonomous driving car doesn't recognize it as a stop sign. Yeah, that's things what really happen.
So if you have a speed limit, you can trick it with like putting a higher speed limit on it and drive faster.
Yeah, you can't really. Your autonomous car thinks you can drive faster, but if the police stops you, it's you still have. Yeah, but the sign still says the right value. It's just tricking the neural network. So I don't know if that's neat use.
One case with the stop sign, you just had to change, I think, the P or something, and then the algorithm thinks it's 40, and then you're not stopping, you are accelerating.
Yeah, often the self-driving cars algorithm work much more similar to trick them, but this could be also approach. Yeah. Any other questions? So. No, I didn't get any offers for the toast.
How much is Tesla paying you that you do not publish it, that you can fake the speed signs?
There are a lot of published stuff around there, and I didn't invent this stuff.
It's quite a security risk.
Yeah, but so there's a lot of information out there. You just have to Google it and a lot of samples. So there are no more questions. We can get to our second spontaneous presentation. Free slides.
Videos, slides.
GIFs. And machine learning is fun.
Okay, welcome everybody. Thanks for joining my talk about machine learning is fun. Isn't it? So who doesn't think it's fun? Hands up. So everybody thinks it's fun? Okay, I mean, it has to be fun. I mean, you just heard that you can even trick machine learning so that self-driving cars crash randomly and so on. So yeah, that's why you want to know more about it. And yeah, let's have a look at what would you think, how would you connect it to see how much fun machine learning is? I mean, you would think that, okay, what do I do with these pictures? I could train an algorithm, right? You train it, you want to play, you're bored of playing yourself, right? You could just take an algorithm, train it, watch from a learning video you just found on YouTube, somebody like a professional Super Mario gamer, and train an algorithm playing as professionally. and you would win all the Super Mario competitions, right? I mean, that's much more fun than playing on your own. Or how to trick a girl falling in love with you. I mean, you could.
Look at the face, so it's Nicolas Cage.
It's my presentation, right? Okay, let's stick to the falling in love theme. I mean, even if it was Nicolas Cage, it doesn't matter. I mean, if you think he's handsome, you want to have him falling in love with you, and that's why you could use machine learning. And yeah, I mean, make a product out of it, Anyline. That's it's much cheaper than buying a Titanic. And it's also safer. I mean, you know. And you could use it for image-to-image translation and interpolation in Latin space. Everybody knows what Latin space is, right? I mean, I'm a machine learning expert, obviously, but nowadays everybody knows it. And yeah, also you see that computer vision experts like to use cat and dog images. It's also fun. It's not the only fun applying it, it's already fun developing it, I would say. Yeah. Yeah, you see that they're not only using still images, they're using moving objects and doing very funny things with it. And yeah, that's how you transform a cat into a werewolf. Any more questions?
Could you please go back to the Nicolas Cage slide?
I see that attract your attention.
Of course. How do I train my neural network so Nicolas Cage falls in love with me? Can you share your learnings?
Of course, you would need the neural network of Nicolas Cage, so his brain basically. You would have to, and then you do basically the same thing that Daniel just explained. You modify your face randomly until the response he gives you fits what you're actually expecting. So, yeah. You can use the same gradient descent learning approach. Yeah, there are for sure papers online. It's a very well researched area. Okay. Other questions? I don't want to nip it down already. Then thanks for my. Okay, there is one.
How far did your Mario machine learning network come? Did he play through all the levels?
Of course.
It's actually unsupervised learning, and it learned Mario playing themselves, and after a few hundred attempts, he could play all the levels. Very interesting.
True story? Question mark?
Yeah, true story.
Okay. I wasn't sure. Okay. Yeah, you should post the links for the viewers on YouTube and Facebook. Thank you.
I think that was also very well done. Thank you. I think you also have deserve free WeAreDeveloper tickets. Good, yeah. please go to Jakob afterwards. So now we look at this a little bit more. And yeah, we are done with the official part. You can all stay here, mingle around, have some talking, drink another beer or another 2 beers, whatever. And I will still keep this slide on for the rest of the evening. Thank you for coming.